Hey guys, welcome back. Let's take a look now at molecular geometry. This has to do with a theory that involves the valence shell electron pairs and the fact that they want to repulse or be as far away from each other as possible. Another way to think of this is VSEPR, repulsion meaning to be as far away as possible. So, anytime we see electrons in an atom, they want to once again be as far away as they possibly can. This will be the basis for a lot of what we look at next. Next, let's look at a simple atom, and that is boron. We know that boron has 3 valence shell electrons, 1, 2, 3. The farthest away they can be is not actually 90 degrees. If you think about a circle, they can actually be further away than this. 1 here, 1 here, and 1 here. We can see that I have made, in fact, a triangle. I'll show you this here. So this will be part of the name. Now, if I show you a 3-dimensional shape of this, you're going to see the second part of the name that we use. So here we go. We can see once again we have all 3. They make a triangle here, but the triangle is in the same plane. That is, all the atoms are on the same level. That is why we call boron trigonal planar. Next, let's take a look at an atom of nitrogen. If we remember from before, nitrogen has 5 electrons in its valence. And we can see up here that we have the lone pair. There are 3 bonds being made, just like in boron, but this lone pair up here is going to really affect the geometry of nitrogen. Let me show you from a 3-dimensional representation. Notice when I draw the atoms connected, they are all facing down now. They are not in the plane as with boron. This is because of the lone pair at the top. You'll also see we have a triangle, but now with the lone pair, we have a peak and we make a pyramid instead of a plane. This is called a trigonal pyramidal geometry. Let's take a look at carbon next. If we remember, carbon had 4 valence electrons on the outside. We know that carbon can get further apart than this because we remember that we're not dealing with circles but spheres, so we can exceed 90 degrees. Let me show you what this looks like in 3 dimensions. First, I draw the first 2 atoms here. Notice they're drawn normally, and then the 2 at the top, representing that 1 is coming towards us and 1 is going away from us. This is called a tetrahedral shape and is very specific to carbon. Tetra meaning 4. 1, 2, 3, 4. Now let's take a look at oxygen. If we remember from before, oxygen had 6 valence electrons. That gives us 2 lone pairs. We would assume that since that makes 2 bonds, the 2 bonds would be right across from each other at 180 degrees. But this is not true due to the lone pairs. Let me show you how they affect. First, I put them here on top, and then now I draw the next atoms pointing down, away. So they are not in the same plane as the main atom. This shape looks bent, so we call it bent linear. That's it. See you next time. Bye-bye.